Hello, everyone. Welcome back to the recitation of CS177. Um, so this has been a pretty uh, heavy week for you guys, I guess, because you had two things to do as usual, though. And today we will walk through Unit 1-3 programming exercise and the lab associated with that. Usually always start by thinking that I'm gonna keep this one shorter than usual. But for this one, I kind of can predict by now that it's gonna be a tad bit longer than the usual recitations, especially because of the lab part because we have some things to talk about over there. And one thing I should point out at the very beginning is there are numerous ways of solving a specific problem. So your solution may not be exactly the same as your friend's solution or your classmate's solution or my solution for that matter. However, I'll try to go ahead and show you several approaches in solving each of these exercises. All right? Okay. So let's proceed with programming exercise 1-3. This was a pretty simple one. So this over here, what's asked for is to make a table that goes from 5 to 15. It prints out that number, the square root of that number, and the cubed value of that number. So right now, what we do is let's go ahead and start writing not the code, but the pseudocode, because that's always the better idea. However, before doing that, just real quick, we need to look at the formatting requirements over here, because that's sort of the key requirement here. The table should be formatted to display the number column as left aligned, 8 spaces, square root column as centered with 2 decimal places. This is important in 10 spaces, and cubed column as right aligned with a thousands comma separator in 12 spaces. So these are the things that we have to be mindful about. And with that in mind, let's go ahead. Okay, let's move on. Okay, so now we're in idle, and I have already jotted down the pseudocode for you guys. This is exactly actually coming from the main idea of the question, which here talks about the number, the square root, and the cubed. So the way we're going to address this is we'll start with the main function, we'll define a main function, we'll initialize some variables if we need to, and we'll set up and print the header as per specification, meaning as they are aligned and with the width size this, and then we'll create a loop and we'll go over the numbers. And inside that loop, we will print out the number, the square root of the numbers, and the cubed values. But we have to be mindful about the fact that the formatting is right. Okay? All right, so let's begin. So let's do def main. And inside main, the next thing would be to create any initializing variables. For the purpose of this specific programming exercise, you don't really need to initialize a variable. Instead, we can hop over to the next step, which is set up and print the header as per specification. So we'll have to print out this number, the square root, and cubed, given the requirements that we have here. All right? Okay. So let's just start. Let's do print, and we'll do format right there. We need to put in 3 things. So we'll do 3 pair of curly braces, and Now, the text that we will want to put inside would be number, square root, so sq root, and of course cubed. But one thing we have not yet done is we did not format them. So we see that the table should be formatted to display the number column as left aligned in 8 spaces. So we do index 0, it will be left aligned, so we put a left arrow there, 8 spaces. Okay, cool. Then what we have is the square root column centered with 2 decimal places in 10 spaces. So we do indexes 1. We want to center this. The spacing should be 10. But and then the last one, cubed, would be 12 spaces long, and it will be right aligned. Okay, so index, let's put index 2. It's right aligned, so we'll put the right arrow there, and 12 spaces long. Okay. And then to finish this off, we would want to underline those texts just like the sample output we have. So in order to actually count how many of these dividing equal signs we want, let's count them. So the first one would be 1, 2, 3, 4, 5, 6. The next then would be 1, 2, 3, 4, 5, 6, 7, 8. So 6, 8, and over here 1, 2, 3, 4, 5. So the formatting remains the same. We do 2, 3, 4, 5, 6. Do 1, 2, 3, 4, 5, 6, 7, 8. And then we do 1, 2, 3, 4, 5. Let's save this and let's try running it to see if we are doing this properly. Oops, we did not call the main function. So here it is. Now it will run fine. There you go. That looks good. However, we don't have the actual numbers, but the header is done. So now the next step is to set up a loop that goes over the numbers. So we will make a loop that goes through 5 to 15. So we'll do for I in range 5 through 16. We write 16 because, as you know, it'll go start from 5 and go up to 1 less than 16, which is 15. And then and inside the loop, what we need to do is inside the loop, we print the values in a properly formatted manner. And actually, we have have done our work already up here because we already have formatted things like 8 spaces left alignment, 10 spaces center alignment, and 12 spaces right alignment. So let's just print this, and instead of printing these dividers, what we want to print are the values that we want to calculate. So in this case, I would iterate from 5 through 15, and then square root of I could be done as I. Let's raise it to the power of 0.5, and then I cubed is I to the power of 3. All right, and well, that's actually not it. We are not finished yet. because let's run it and see what we are missing. It's, okay, so you see that we have some output, but it doesn't exactly look like what we are expecting over here. And if you have watched carefully, you'll notice that the reason is that the square root column has to be centered, but it has to be with 2 decimal places. But we never did anything about that. So in order to format that in 2 decimal places, what we will do is put a point to F, and that dot to F is for 2 decimal places with fixed point. All right, and that should take care of the 2 decimal places part. And another thing that we have not done is we did not put the comma in the thousand space in the cubed portion, which it asks for. Because if you go back to the question, we see that it says the cubed column has right aligned with a thousands comma separator. In order to do that, so this was the placeholder for that, we put a comma. And that should do it. Let's run it and see if we are getting what we are expected to get. All right, cool. So that was programming exercise 1-3. But I should point out that there are other ways you can do it, like slightly different ways. For instance, instead of raising this to the power of 0.5, we could have used from math import sqrt. And over here, instead of doing that, we could have done square root of I. That would work the same way. You see, it's the same output. So there will always be multiple ways of doing a certain of solving a certain problem. All right. Okay. So that was the programming exercise. Now we'll move on to lab 1-3. Okay. So now let's go ahead with the lab. Um, so before talking about the actual parts of the lab that you have been asked to do, there's one part which is not written over here, and that was to read chapter 5. And reading chapter 5 from the textbook was essential in doing this. And if you had done it, you probably had an easier time doing this. And because several concepts like string manipulation, encoding characters to ASCII values, and things like that have been covered in the book. So my suggestion would be before starting any of the labs, please read through the whole text of the handout and the instructions. And when it says to read something, do read that, because that does help, and that's there for some reason. Okay, so okay, let's just go ahead. So in this lab, what you are asked to do is that to take 5 keyboard inputs from the user, and it will print them out in form of a table with 4 columns, and they are first name, last name, age, date of birth, and a numeric value associated with each name. And we will talk about what they are. Okay. And then in part 2, you are given a pseudocode, and this is sort of like handed to you. So this is really helpful. And again, one of my major suggestions, and this is coming from not only me but from all the TAs and of course, I'm sorry, professor, is that you should be writing pseudocodes before you write some real code. And for this bit, we are going to verbatim. I'm sorry again. Take this to the main code, and then we will translate this into a real Python program. So right now, what we now let's just read through this. All right, we are going to define a main function, And whenever a programming assignment or a lab tells you to do a main function, you have to do a main function for that, or any other named function for that matter. For instance, in the programming assignment, programming exercise 1-3, the one that we just saw, that didn't have this requirement. So you could get off the hook for that one. But when it says that you have to define a main function, it is a requirement. All right. Okay. So then we will display a description of the program's function. We initialize some variables that are needed to be done initially. Then we set up a for loop, which will repeat 5 times, each time for a single person. And for each of those inputs, we will prompt the user for a set of values, which are the inputs. Then we will take the last 4 letters of the last name and calculate the numeric value of each name. And this numeric value is the summation of the ASCII values of those characters. And there are some corner cases or edge cases, as we say in computer science, where there might be less than 4 letters in the last name. In those cases, we will just take as many as we have. Like if it's a 3-letter last name, we will take those 3 letters. So we will be expecting you to handle that situation as well. And then we are going to store the user input and the calculated numeric values in a list. And then we will display a table header, and there will be an example coming up. And then we'll set up another loop which will iterate through that list, and then we will format those list values to create the rows of the table. So looks quite a bit of work, but it is definitely manageable because we have seen all of this. Okay, and there are some requirements given here, like some examples. For instance, the keyboard inputs will be in the form of this, like first name, comma, last name, comma, age, comma, date of birth. So we will be only testing with valid ones. So we are not going to put in like 10 different things separated by commas. We are not. So don't worry about that. Assume that the inputs will be correct. Then we will store the inputs and the calculated values in a list where each entry is a string. So it will be a list of strings, and each of those entries will correspond to a single user input and the calculated value. So if you notice that the input were these 4 things: first name, last name, age, and date of birth. But when we will turn it into a list, it's not going to be 4 things, but 5 things, because we are adding this value attribute. And we have to actually calculate that. We have to come up with it. And once we are done with creating a list of 5 such strings for 5 people, these are the formatting instructions that the first column is called first, and it's 12 spaces long. The alignment will be left. Last is 12 spaces long, left aligned, and similarly, you can see the rest. And another important thing that some of you guys have missed, or maybe I have missed myself, is that the overall table is 57 columns wide, meaning it's horizontally 57 characters long. And why is that important? That is important into figuring out how long this line would be, or how long this title should be centered at. So that number 57 comes in handy in this specific case. All right, so what you see here right now is a sample output. So this is what the program would look like in the end if everything works out fine. Okay, so now let's go ahead and take our pseudocode and make some more pseudocodes out of it. Okay. So I took the pseudocode from the our handbook and put them in here just as a guideline for us to go through and writing the actual program. So let's go through this once again, just once more, because this will come in handy. So initially we have our formal header, and then we have the pseudocode. So we're going to define the main function. Then we're going to display a description of the program's function, which would look like this. Observe that this is center aligned. So this is important. And initialize any necessary variables. We set up a loop that will repeat 5 times. And in each of those times, we're going to prompt the user for a set of values. And from here, you can see that each time we're going to ask for like one string, not first name, give me first name, give me last name, give me age, give me date of birth. No, uh, we have seen some submissions that have some that are set up like that, but if you have read this part, then you'll see that the input from the keyboard will be of the form first name, comma, last name, comma, age, comma, date of birth. So it's not different strings, but one single string for each person. Like if you if you're a fan of basketball, you know these people. They're like the famous basketball players. Anyway, moving along, and we're gonna take those inputs and then using the last four. Let's make a new line out of this. The last four letters of the last name will calculate the numeric value for each name. And we're going to store the user inputs and the calculated numeric value in a list. Then this loop is done. Then we're going to create a table header. So we have seen the example output, and we will go back and forth to just match up with that. And then we will set up a loop so that we can print all the information, just like what is presented here. Okay. All right. Now, one thing to point out is even though you are given a pseudocode, doesn't necessarily mean that it has all the details inside of it. So let's say over here we have using the last four letters of the last name, calculate the numeric value for each name. Now, for the understanding of our own convenience, I am going to break this down into some more steps, like the way would want to solve this. All right? Okay. Now, another thing I should point out is that I mentioned at the beginning that there are numerous ways of solving a specific problem or writing a specific program that does something. So this is going to be our first version. Let's call it version 1. And over here, we are going to do everything as asked. But in version 1, we're going to do this calculating the value using the last four letters in one way. And in version 2, we're going to look at a different approach into doing that. Having said that, let's start coding. So first, let's define the main function. Let's do def main. That's fair and simple. Now we want to display a description of the program's function. Now we will do print. Observe that initially I'm not going to format anything, but then we are going to build it up. Okay. So what should we print? We want to print this program takes in 5 keyboard inputs from the user. Okay. This program takes in 5 inputs. Okay, keyboard inputs from the user. and that's it, and, right? And then we have a new line. There are two ways of going about this. We can have a new line character, or we can simply do this in a new print statement. Let's do the easy way. Displays an organized report with multiple columns, which are another line. First name, last name, age, date of birth, and a calculated value. Okay. First name, last name, age, date of birth, calculated. Now what you see is we have a blank line here. So in order to make a blank line, we can simply do an empty print there. And now we need to make this long separator line. And if we look at the specification, we can see that the overall table is 57 columns wide. So we need 57 of those. So what we can do is we can print 57, I'm sorry, the equal sign, and we can multiply it by 57. However, just make a note here that if you want to do like more work and you want to like do this manually, like 1, 2, 3, 4, 5, 6, 7, and press that 57 times, it's gonna come out to be the same. But we are computer science. We are doing computer science, so we don't want to do manual work too much. Okay. So without any formatting, let's run this and see what happens. Oh, rookie mistake. Oh, the problem was that we did not indent our code properly, so it didn't know that this was inside main. So let's run it. Come on. Okay, nothing is being run. Why? Because we made a main function, but we never called it. So we need to call it. Also, let's have line numbers. Now let's run it. Okay, so it looks like that. But do we want it to look like that? No, we want it to actually be center aligned, right? So in order to do that, what we do is, let's go ahead and use the format statement. Dot format, put this whole thing inside format. This is 57 spaces long, and it's capital, it's centered. And we will do the same thing for the next one. Dot format, take this, take this, take this. Again, take format, take this. And also this one. Whoops, we have not done format, so we'll do. We're gonna fix some typos. Let's fix the typos and make everything line up. Okay, does everything look fine? Looks good to me. And let's run it. Okay, we made some mistake somewhere. Uh-huh. So, you know, everyone makes mistakes. Forgive me for this. So we forgot the quotes. All right. Now let's run it. Oh boy. In the wrong place. But the rest are fine. Okay. Now it should be okay. All right. Okay. So do you see the difference from that to this? Now everything is center aligned with the separator line. Okay. Great. Now, what's the next step? Since we've done quite a bit, we need to think about our steps. So we are need to initialize new necessary variables. So let's call the value that we're going to calculate. We'll call that V, but we're going to do that in just a little bit. But before doing that, what we want to do is we want to make a list, all right? Because we will need a list, if you recall from the program statement, that we want to store everything in a list. So, so this is where pseudocode comes in handy, right? So we have initialized a variable. Now we are going to set up a loop that goes through loops 5 times, and we are again making a mistake. We need to indent our things properly. Now what we need is for I in range 1 through. You can do that, or you can simply do this. They both work. But since we want to have an input that says input 1, this is what the print statement would look like. It would be better if we do 1 through 6. That way I moves from 1 to 5, like 1, 2, 3, 4, 5. Okay, so let's now the next step is prompt the user for a set of values, and let's do that now. Make some spaces. So let's call it enp, for lack of a better term. To input. Now inside input, I want it to say this: input number 1 and then 2 and such and so forth. So what we do is input number. Now here's the catch. Now what do? We need to put in a number that gradually changes, right? Initially it will be 1, then it will be 2, and such and so forth. So let's concatenate strings. The value of I goes from 1 to those numbers. Then there's a colon, if you notice this. Okay, so let's run this and let's see if we are doing okay or not. So we can do Kyrie Irving 28. Let's make up a birthday. 2000. Mm, let's make up names. Tom Smith 22, 12, 4, 20, 10. Um, okay. Kobe Bryant 3, 4. Let's do 1, 1980. And let's just go with AB 12, 1, 2, 2. That's okay. So the Q R 1, 1, 1999. Okay, so you see that the number is actually changing. So 1, 2, 3, 4, and 5. So we're good. So the input part is done. Hooray. Okay, so now that the input is done, let's go ahead and do the more algorithmic stuff. So we will be taking the inputs as strings in the string called INV over here. And now what we need to do is using the last 4 letters of the last name, we'll calculate the numeric values for each name. However, before doing that, what we need is to have some way, let's write it down. We need some way to get the last name out of the comma separated inputs. Now, how can we do that? The way we can do that is because the inputs are separated by commas, we will split it into multiple strings and dump them in another list. So let's call that just let's call it input list, and since we have the full input with the commas inp, we need to do inp dot split, and we will split it based on commas. Now once we have done this, what will happen is the first name will become a part of input list index 0. So this is first name, and then similarly the second index, which is index 1, is going to be last name, and so forth. Okay, all right. So now that there's a way to get the last names, let's have a variable called last name. Now let's just make it one word, and it will be input list at index 1. Okay. All right. So just so that we know that we are doing it right, let's just print it and let's see if we are getting it properly or not. Okay. So we'll do last name after splitting is, and the variable name. Let's do that. Okay. And since we're just testing this out, we don't want to do this like 5 times. Let's do it just once. So I'm changing the 6 to 2. And with that, let's run it and see if we are getting our expected output or not. Okay, so let's do Kyrie. Okay, 28 made up per day. So last name after splitting is Irving. So this is okay. So that's a proof of concept. It's always a good idea to test things as you go along. All right. Okay, now we reverted back to 5 people. So now that we have done that, the next work to do is using the last 4 letters of the last name, calculate the numeric value for each name. So now how do we do that? You need, before calculating the before calculating the value, we need to first take those 4 letters. Now, how can we do this? Actually, there was a frequently asked questions FAQ post on Piazza that was pinned, which gave you guys an a method to do this. I'm gonna do the same thing here. And this will be a refresher of in string slicing. So in order to get the last 4 letters, what we do is, let's say, let's have a variable. Let's call it last 4, and we'll assign the last names, last 4 letters. So what we do is they do -4, which means go from the last most 4 and go up till the end. Okay, so that. Now, just to check that if we are doing it right or not, let's do the same thing again. The last name, last 4 letters is, we called it last 4. Now observe one thing, that some people may not have 4 letters in their last name. So even in those cases, this specific code is going to work because it's just going to take the last, at least, at most last 4 letters. So if there's a 3-letter last word, it's going to take those 3. And that's what we're looking for. So we are going to test this out with, let's say, 2 names, one with more than 4 letters in the last name, and one without. So let's run this and see. Okay, we'll do Kyrie Irving 28. Let's do 2000. So you see the last name after splitting is Irving, which is fine. Last name's last 4 letters is Ving, which is also right. Okay, and now let's do James. Now, I'm gonna do this intentionally. We're gonna do joy. So that's less than 4 letters. And 22 years old. Let's do make him 1st Jan 1999. Let's see what happens. So last name after spelling is Joy. And last name's last 4 letters is also Joy. Okay. So now what we need is using these last 4 letters, we want to calculate the numeric value for each name. So we don't need this print statement anymore. Let's get rid of this. We also know that this is fine, so we can get rid of that. And now this is version 1 of the solution. So this is one way of doing this. So one way of doing this is we are going to take each of those characters. So we will take each character of last 4 and sum up their ordinal values. Now what's an ordinal value? Ordinal value is an ASCII value of a specific alphabet. Now the thing is, for our calculation, we want A to be 1, B to be 2, C to be 3, and so forth. So if you look at that specific function, ord, we will see something interesting. And this ordinal function should not be unfamiliar to you because it is covered in chapter 5 of the book, which you should have, it was part of the tasks, all right? Okay, so let's use the shell and let's just see what happens. So ord of A, the character A is 97. So, and then ord of the character B is 98. But we want A to be 1 and B to be 2 and so forth. So if we subtract 96 from each of these, they will line up, right? So that is the clever strategy of solving this issue. So we're gonna go through each of those characters and sum up their ordinal values and adjusted by 96. Let's go ahead and do that. So 4. Okay, one more thing. Since we will be storing this, we will be processing and storing this value, we need a variable to actually store this, right? So we will store the value, the sum, in a variable called v. So let's initialize v to be 0. And now we'll do the loop through the characters, all right? So let's do for x in last 4 v plus equals, that means for each iteration or for each letter, you're going to add up to v, whatever we are going to write now. So that's going to be ord of x minus 96. Okay. So just so we know that we are doing it right, let's do a print test and see if you're doing it right. Value is str, and let's do v. Okay. And since we don't want to do like 5 or do this. Let's do just one. So we'll go ahead, we saved it. Now we'll run it. And before doing that, let's just go ahead and check something, that Kyrie Irving will have value 52. So if we get 52, it'll be good. So if we do Kyrie, comma, Irving, comma, 28, 12, 12, 2000, and enter. Oh, turns out we are not getting a mistake here. The reason we are not getting a mistake here is because we are calculating the 4 letters of VING, so that are all small letters. However, if you notice, if the ord of A was 97, but ord of capital A was something else, 65. So in case in the event we were to do this again, let's just do this for kicks. We do Kyrie and we do IRVING in all caps in the same values. I'm trying to do 12, 12, 2000. Then you see that we get minus 76. So this is not what we want. We want our answer to be the same, even if we have all caps or this like a mixture of uppercase and lowercase. So the ideal way of doing that would be when we make last 4, we take the last 4 letters and we force it to be lowercase. And now let's run this. Okay, Kyrie Irving in all caps intentionally. 28, 12, 12, 2000. You see, now we get 52, not minus 76. So this is what we want. So, okay, cool. Now we know this is working fine. Now that this is done, what else do we have to do? So now what we want to do is we want to store the user inputs and calculated value in a list. And we already decided the name of that list initially. We called it capital L. And we will do that. For that, let's fix up our loop. And the entries in that list would look like this. First name, comma, last name, comma, age, comma, date of birth, comma, value. But right now, we only have first name, last name, age, and date of birth. We don't have this value part in our string. So the next step is going to be get the value inside our string. So how do we do that? Right now, the first 4 things, first name, last name, date of birth, age, and date of birth, are in the string called INP. Okay, so let's have another one. Let's call it list str. And over here, we are simply going to take our initial input string, which is this. We are going to concatenate. That's a fancy word for joining, like put 2 things together. So comma, plus str, and we want the v, which is value. And just so we know that we are doing it right, we want to print out the list that we will actually create. So first, let's just print out the string we just made. Print the string with 5 things is, let's do list str, and that should do it. And before running that, we'll just pick up some paste, and once that string has been made, we will simply append them or put them inside the list that we are creating for all the inputs. So we will do l dot append list str. One thing, let's print out the list just to see if we are doing it right or not. Okay, so what we'll do is the list of inputs look like this. Put a colon there. Let's print out the list. And everything looks fine. Let's go jump ahead and run it. Okay. Let's do Kyrie Irving 28, 12, 12. Oh, I missed a comma. 2000. See that we got the right answer. So 52 is fine. So LeBron James 33. That's 1999. That's 38. So LeBron is 38. So we're getting this right. Let's do KD, Kevin, Durant. Let's make him 22. 1 2009. Okay. Now let's just make up some name. Okay, another one. Or maybe we can just have this person again, just to save time. Okay, so the list of inputs look like this. Kyrie, comma, Irving, comma, 28, 12, 2000, 52. Next entry, this, next entry, this, next entry, this, next entry, this. So is this what we're looking for? So first name, last name, age, date of birth, value. So we have first name, last name, age, date of birth, value. Again, first name, last name, age, date of birth, value. The first name, last name, age, date of birth, value. So next step has been done. All right. So cool. Now that we have that in order, we can get rid of these print statements. We don't need them anymore. Now what we need is to make the table look exactly like the way we want it to look like, right? So let's go ahead and look at the table real quick. So we need to make a header first. So first, let's make a header. Actually, if you look at the header on top, we can actually reuse this. So let's go ahead and reuse that for now. So we can take this and for the table header, we are gonna put it there. Now, notice one thing, that this thing is not inside the loop. The loop ran from here to here, okay? To line 51. So this is not inside the loop, this is outside the loop. So there are two of those lines actually. And in between, we're gonna have the column names, like first, last, age, date of birth, and value. So the way we do that are given here. So these are 12 characters long, left, 12 characters long, left, and so on and so forth. So let's make them act as such. Okay, so I'll have 1, 2, 3, 4, 5. So we have 5 things. So 0, colon, how wide is it? 12 characters wide. So 12 characters wide. It's aligned to the left, so we'll do a left alignment. So again, what do we have? Again, 12, but this time index 1, left aligned, 12. Now, what else? Now we have age. Age is 3 characters wide, and it is right aligned. Okay, so index 2, it is right aligned, 3 characters. Then we have date of birth, is 25 characters long. So index 3 is 25 characters long, and this is centered. Okay, so let's make it centered. Cool. And finally, we have value 5 characters wide on the right. So index is 4, 5 characters wide. Okay. Now we're gonna do format. And now we are going to print in the names. But how do we do that? We have 5 names and we have this inside what? Like this is not inside a loop actually, but we don't need to put this inside a loop because we are only making the header at this point. So we can just throw in the text. So we can write first, comma, last, comma, um, age, comma, TOV, comma, value. And that should be it. Okay. I believe we are ready to test this out. Let's save it. Let's run it. This time around, I'm not gonna spend time typing this out. We'll take the old ones. Let's put it in 1, Kyrie Irving. Let's take LeBron James. Okay. KD. And then some dummy inputs. All right, so you see that we have the headers ready to go. Okay, so now that the headers are done, let's go ahead and make a loop using the list values as sequence, and then we'll work our way through the formatting of the stuff. So let's do for I in range 5 because we have 5 people. Now what do we do? Now here we need to think about it just a little bit because we have all our things in this list called L, and from L we can actually take out each person one at a time and then use their information as a single string. So this is kind of like working our way back. The meaning L of, let's make it as a comment, L of 0 is actually a list that has, let's say, Kyrie, Irving, and so forth. And then L of 1 is another person, whoever the second person is, right? Okay. So in order to actually parse these properly, what we will need to do is remember what we did initially. We made a split, right? Using a comma right there. So that's exactly what we are going to do. So L of I is basically one person, and this is basically a string, so we can split it. It's BLID. We split that by a comma, and we can store it in a variable. Let's call it Q. So now the list Q has everything lined up where index 0 is last name, index 1 is first name, and such and so forth. So we can actually parse that out between first name is assigned to Q of 0, last name is Q of 1, age is Q 2, date of birth is Q 3, value is Q4. And now all that remains is to print this out. And if you notice that we have actually done the groundwork for the formatting up here in line 57, because this is exactly the way we want it to be. And that's exactly how we define that. So we can copy this, paste it. Now, instead of these static variables that we had, we're gonna just, instead of static text, sorry, we're gonna put in the variable names. So last name is gonna be last name, age, oh, sorry, let's make it age. We call it TOB, so just remove the string. Value is called value, the small v, and that should take care of our lab. Let's see if we made any mistake. So let's go ahead and try running this. Let's use the same values as before. Kyrie Irving, LeBron James, Kevin Durant, this made up input, this made up input. All right, let's go back and see. Yep, I believe we are complete. So, okay, cool. So I hope you saw how we actually moved from a pseudocode to the completion of a specific lab, right? So it's always a good idea to write out a pseudocode. But in the beginning, I actually promised you that we're gonna do it in two versions. So let's just call it lab 1-3 v1. And now in the second version, I'll keep everything same, everything similar, except this time instead of calculating value using the OR function, let's do it in a different manner. All right. So this is version 2. So for this, actually, I've seen someone do this in this manner. This is not the most efficient way, or this is not a way that I would have done it, but you can do it like this. Let's have a list of letters. Let's call it letters. And in that list, we'll put A, B, C. I'm sorry, please bear with me. Okay, E, F, G. Oh God, let's just copy this over and oops, whoops. Well, you get the idea, right? If G, H, I, J, K, L, whoops, L, M, D, U. I'm so sorry. I'm sorry, you guys, that you have to see me say alphabets. E, U, V, W. Oh God, X, Y, and Z. All right. Okay. Oops. Where did I lose it? Okay. Let me just check if we did it right. A B C. A B C D E F G H I J K L M N O P S D U V W X Y and Z. Okay. So now let's do let's do an experiment. All right. Let's have this here in the shell. And now let's say I want to know at what index A is. All right. So what we can do is letters dot index, and inside index we can put in A. You see that that's in index 0. So, and what about B? This is in index 1. And what about, let's say, Z? Okay, so are we missing a letter? No, everything's fine. Okay, I'm sorry. Sorry about the delay. Anyway, so one problem that you see is that A is in 0. So we don't want A to be 0. We want A to be 1. So what can we do? What we can do is, instead of having A over there, let's put in a dummy character as the first one. Let's do a hyphen. Okay. So now if you do this, we get 1. All right. Now if you do B, we get 2. All right. Okay, I think I see the problem here. There was no comma between N and O. Okay. Phew. Okay, so now we sort of have a way of dealing with this using alphabets. Okay, so now that we have these letters over there and we have the last 4 letters in the variable last 4, so we create a loop just like before, like for x in last 4. This time v plus equals, instead of using ORed, let's simply, we are going to add the index value of whatever alphabet that is. So we will do letters dot index, and inside we want to put in x, because x is the letter every time that we encounter each of those last 4 alphabets. All right, and everything remains the same. Okay, so let's go ahead and let's save this as lab1-3 v2. Let's go ahead and run it. Hopefully everything will be fine. Let's take the inputs like before. Kyrie Irving. Let's put him here. LeBron James. Here. Kevin Durant. Put him here. And the dummy inputs that we had. We could have just used the same one though. Okay, does this line up with the same? 52, 38, 53, 34? Yes. So we get the same answer using a slightly different approach. So, well, that was lab 1-3. Thank you so much for bearing with me today, and best of luck for the exam that's coming up. And just before leaving, uh, I just want to emphasize something, and that is these are not the only two ways of doing this lab. There can be several other ways of accomplishing what we just did. All right. So there are multiple correct answers. So if your one doesn't really line up with exactly this, it doesn't necessarily mean that it's wrong. It could be, but these are uh, two plausible solutions that one could do. So it's more about the process than the actual output in this specific recitation today. All right. So thank you so much. Have a great week ahead. Bye.